Hi everybody. Today we are going to talk about acid-base indicators and how to read table M in your reference charts. So we're on this page in the notes. I'm going to be going through and adding the notes. You could follow along in the note pages that are already filled in for you. But we need to go through and just talk a little bit about how to read table M when we're dealing with the acid-base indicators. So you have a little bit of an introduction with acid-base indicators with the WebQuest. I believe that they discussed the universal indicator. When you did that WebQuest with like the salsa and all that, and you dipped it in, you saw all these different colors from 0 to 14. In the POGIL, you had litmus colors listed as one of the properties. So what an indicator is, it's a chemical that changes color within a pH range. And the key word there is range. So when you're talking about an indicator, you're not going to pinpoint the exact pH of a solution. You're going to get a range, a pH range that it could be within. So we have table M on our reference charts. And what this does, the way that we read this, and I'm just going to throw this here. Perfect. So when you look at this table, they give you in the first column 6 different indicators that you'll be required to use for questions. They give you a pH range where there's a color change, and they tell you the color change that occurs within that range. So if we take a look at the first one, I believe I have methyl orange. Yes, we have methyl orange. I'm going to write down, let's just bring this all in the same view. Good. I'm going to write down for methyl orange, its pH ranges that it's going to be specific colors in. So according to table M, it says from 3.1 to 4.4. Methyl orange will go from red to yellow within that range. So once you have a solution with a pH of 3.1, it's probably bright red. And then as that pH starts to increase, that red goes towards an orange color, and then the orange goes towards a yellow. So this is telling us that within that range, that 3.1 to 4.4 pH range, we get that, color change over the course of those pHs. So what about outside that range? Okay, that doesn't tell me anything. If I can't pinpoint the color, I can't even tell anything about, what the pH is. Well, anything below 3.1, 0 to 3.1 will all be red. That is where I have a definite color. And anything above 4.4 all the way up to 14, that will always be yellow. So that's where the significant and the definite color changes are going to come in. So you can't determine an exact color when you're within a range. So if I said methyl orange turns a dark orange color, what's the pH range? Well, how dark? Is it closer to red? Is it closer to yellow within that range? The only colors you'll be asked about for methyl orange are going to be red and yellow. Okay, so that's why up here I have pH of 2 is going to be red because 2 is within this red range. It's less than 3.1. If something has a pH of 6, it's going to be yellow because it's within that 4.4 to 14 range. But a pH of 3.5, I couldn't tell you. I couldn't tell you exactly what that color is going to be. So that chart basically tells you the color before the range and the color after the range. And it's going to be those two colors that are listed there. Okay, so let's take a look at another one. Let's say I have litmus. Okay, let's say we're going to use litmus. And I want to figure out what colors litmus is going to turn within specific ranges. Well, I take a look at table M and it says litmus has a color change from red to blue when there is a pH range of 4.5 to 8.3. So I'm going to put my 4.5 to 8.3 right in the middle. All right, and this is where we're going to go from red to blue. Okay, so again, within that range there, that 4.5 to 8.3, I could not tell you exactly what that color is going to be because it's slowly changing. But I can tell you that anything from 0 to 4 will all be red. Okay, because from 0 up to 4.5, it's red, 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 and then we hit 4.5, and then it starts to change over to blue. Once I hit 8.3, we are set. We are in that blue range all the way up until a pH of 14. Okay, so if I threw out a couple pHs, let's say a pH of 2, let's say a pH of 3, and let's say a pH of, oh, not 4, 10. Okay, what would the color be? Well, pH of 2, that's for between 0 and 4.5, so that is definitely going to be red. pH of 3, also going to be red. All right, this is why you can't determine an exact pH. Okay, so you can't determine an exact pH value. You might be able to narrow it down by using multiple indicators, but if I just said, hey, here's litmus and it turns red. Okay, what's the pH? Well, you can't tell. All right, you could say, yeah, it's between 0 and 4.5. There you go. That's the best you can do. And if you have a pH of 10, you're going to get that blue color. Okay, so this is how you use table M. Okay, so just remember, the first color listed is going to be 0, the pHs of 0, up until the first number of that range. Within the range, that's when the color begins to change. We can't pinpoint it. You won't get questions asking you about anything within that range of pHs. Then the second number, the end of the range, all the way up to 14, that's when you'll have that second color and that second color only. All right, so let's just take a quick look. I have some practice problems posted for you guys. If you take a look, you got some multiple choice questions here. What I want you to do is to cross out number 8 when the reference charts got updated. A few questions were not being able to be answered because they changed those ranges slightly. So some of our answers were off a little bit. So just to give you an idea of what you're going to see. All right, so question number 1, phenolphthalein is pink in an aqueous solution having a pH of what? Well, if I go to phenolphthalein, I see that it's colorless from 0 to 8, and it's pink from 9 to 14. Okay, so it's going to be pink after it hits 9. The color changes from 8 to 9, and then 9 above, it's going to be pink. So I'm looking for a pH that has a value within that 9 to 14 range. All right, number 2, what is the color of the indicator of thymol blue in a solution that has a pH of 11? Well, thymol blue goes from yellow to blue when it's going from 8 to 9.6. That's going to be yellow to blue. So anything above 9.6 will be blue. And if they're saying that we have a pH of 11, well, that is definitely greater than 9.6, so our pH would be blue. All right, let's just take a look at one more here. Number 3, 3 samples of the same solution are tested with different indicators. All indicators, bromthymol blue, bromcresol green, and thymol blue, appear blue. All right, so I need to make a little list of what ranges bromthymol blue, bromcresol green, and thymol blue will all turn blue. So bromthymol blue turns blue at 7.6 and greater. Bromcresol green turns blue at 5.4 or greater. And thymol blue turns blue at 9.6 or greater. Well, I'm going to use that highest number to narrow it down a little bit, because this pH, I know the pH of this unknown solution has to be 9.6 or greater. Otherwise, that thymol blue would not turn blue in those lower, it would not have a blue color in the lower pHs. So I know that I'm looking for something with a pH of 9.6 or greater. So this is how you use multiple indicators to narrow down what your pH range could be. So I could say that the pH range of this solution is 9.6 to 14 based on this information. And 9.9 is going to be our answer, since that's the only one that falls within that particular range.